Fire in the hole. Welcome to Fro-Dog Arcade Repair in Sanwa number 6. Still got that Harry Belafonte in my head. I saw Beetlejuice recently. 5 San, 6 San, 7 Sanwa. Sanwa broke and Fro-Dog fix it. Alright, let's do our visual inspection. There's my trusty little pocket screwdriver. First thing I see is we got a broken ear here on the flyback. Caps look original most places. Let's see. Alright. Well, it'll be interesting to see if that nope, that filter cap is not original. There's a little bit of glue on the board, but no glue on the unit. These two caps in the power supply, probably original. Well, maybe not. Their glue, or the glue, is not stuck to them. It's just flipper flapping there. That one's definitely glued in. This one's been replaced. Let's see. C312. C312 should be 470 mic at 50 volt, and it is 470 mic at 50 volts, so that's right. This is different. We'll have to see what that is supposed to spec out at. What's in there is a 5.6K at 5 watt. Where's our resistor number? R415. Let's make a note of R415 and check our parts list. Sanwa 7 R415 value. So anytime, what I've learned on the Sanwas that I have bought blind on eBay is that there's reason. Either cracked board or burn up components, flyback's funky, something's going on. I believe this is a replacement flyback at some juncture in its life. Just like Sanwa number 4. It lit off and fired up pretty easy, but we had linearity pincushion issues to chase. This one, I don't see anything looking going on there. We do have a small corner chunked on the board here. We'll delve into that. We know how to fix that. This resistor is a little crusty down in there. Should probably take that out, clean it, reflow it. I don't see any burnt components in here. Let's take a look at the neck board while we got it up here. Some resistors folded over as usual. We'll try to straighten that stuff out. Ooh, that one's folded over and shortened against the diode there. What about connection-wise on our CRT board? Things look pretty good. I don't see any glaringly obvious problems there. We are going to have to fix that flyback here in the corner of the board. Those are the structurals. Let's start with our fuses. That should give us a little bit of an indicator. Both fuses check good in circuit. I'm going to pop them out. Yep, crusty fuse holders again. What is our value on this one? 4 amp. That is correct. Let's check it out of circuit. Yep. All right, let's pull this one out. What value is it? 1.6, that is correct. Test good out of circuit as well. I think our fuses are good. Let's go over to diode. Let's start in the power supply. And first, are any of our legs shorted to ground or the heat sink? No. All right. Put our meter over here. Yeah, you can kind of see it. Let's see. Got a junction. Those two I think read. Yeah. I think that is good. Yeah, that filter cap's been changed. Let's look down in here. Oh, there's something interesting. I wonder if we got a B+ problem on this one. Look right down in here. Let's move this over. That B+ pot there is a replacement, and it is facing the wrong way. Should be adjusted from the outside here, and it points to the inside. So we got to see what's going on with that. Probably just the leg setup on the replacement pot makes it go in opposite. So that may not be the end of the world, but we'll see what we can do to turn our luck around there. Let's take a look at our HOT. First, anything dead shorted to case ground? Nope. I think two outsides will read shorted because of the flyback in circuit, and they do. And we got our junctions. If I can get my meter leads in there. Oh, there it is. That's what I was looking for. Okay, those all look reasonable. These pots look reasonable. That might be a replacement cap there, not 100%. I think that one may be as well. No glue on it, and I see where the glue used to go. That one's a replacement, which means its little look-alike buddy next to it's a replacement. Can I see a brand on those? I can't. My gut says that if we put this on the tube, it'll light up, but it's going to have some sort of other issue. It's not going to be as likely to be power or high voltage. Let's look on the bottom side. What do we got? Oh yeah, our flyback's definitely been replaced. Our heat sink over here, we don't have a cracked board, but we have a lifted pad for the heat sink. Got a little bit of rub here. I don't think that's a big deal. Those header pins look like they've been flowed. These have not. I don't see anything egregious connection-wise. Those have been touched up. A little globby there. Oh, what do we got here? Had something happen with a trace here. And something with that transistor, so we'll look a little more there. I don't see any broken or ringed stuff. I question that value on our 415. Of course, I'm going to question the pot value on our B plus pot, which let's just double check a marking on that. VR 451 maybe, 851. VR 851. And we're looking at our parts list. We're going to check our value on that as well. 851 value. And where was our mangled up trace? It's over here. Oh, it's at Q403. I'll bet you loose connections at 403, soldered a little bit, and probably just lifted the pad. So we'll clean that up and make that right and tight. Uh, 680 at 200. We'll check that value as well. I question it a little bit. I think it 200. I don't know if that's stout enough voltage. C805. C805. Got that one wrote down. All right. Well, I think we'll check those values in the parts list and see that they're right as a starting point. Those, what, 3 component values that I was questioning. And then I think we'll do a little bit of reflow work, just kind of tidying up some connections. This Q403, let's just check it with a meter. We're still in diode. We got 2 junctions, nothing shorted. I'd say it's probably okay. I just would like to see that pad repair done a little differently, a little better. Our little 1K mod on the outside over here is in place and intact. Our Q801, that is our transistor in the power supply section. Looks a little crispy, but not, I mean, I've seen way worse. It's making good connection. You know, this, let's ohm that out at Q403 and just, not ohm it out, but continuity check for the trace. I think it's making continuity. That leg seems to be. Yeah, I'd say that's fine. Okay, we're here with Sanwa number 6. First off, I found my Fluke 79 that I have been missing for quite some time, and I found it in a tool bags that I had put together to go out for an auto repair. So I've got my Fluke 79. The funny thing is that red meter that I've been using, the cheapie off of Amazon, I actually kind of like it. And it's kind of hard to go back to the Fluke. But we found some interesting stuff here on Sanwa number 6. One is took the flyback out to repair the ear on it and to make easy access for the caps back in the flyback area. I did a bunch of reflow work and a bunch of cleanup work on the board. Now, I have not alcohol cleaned this with a toothbrush yet. And there are a few places where I see the green coating coming off, that kind of stuff. And we do have, it's on this corner, our busted corner. We'll repair that the same way we did the other stuff. We'll Dremel up the edge, make a nice edge on it, and we'll use the CA repair kit. Something I have not addressed yet is our Q403. Now, we have found that to be sketchy solder joints on other chassis. This one is a little, it's got a repair. It looks like maybe some pads were damaged or whatnot. I want to remove that solder and see what we're really dealing with, but it's not insurmountable. We'll get that corrected. We've got some epoxy drying on the ear of our flyback that where the screw went through. We've got our board generally cleaned up. Things are tidied and looking pretty good. Did replace our fuse holders. But I noticed that there was some disturbances in the power supply section. And the first thing I did is I did check the power supply transistor. And it tests okay. But it's the wrong part number. The 2SC4138 is a power and switching transistor like the correct 2SC3831, both from Sanken. The difference is a 3831 is rated 500 volts 10 amp and a 4138 is 400 volts 10 amp. Now, did it work? Will it work? Will it work long term? I don't know, but based on what the manufacturer spec'd, it's underrated. So we're going to replace that, put the correct power transistor in. Other thing I found was a 3.9 ohm resistor had been replaced. And that looks like, oh wow, either a half watt, might be all the way up to 1 watt. I think it's probably just a half, but it is spec'd at a 1/4 watt. You know, now to lay those side by side, I bet that is a 1 watt. Should be spec'd at a 1/4 watt. We're going to replace that as well. And this is the chassis that had the B+ pot that was replaced. And if you look at the leg configuration, legs are backwards, and the B+ pot pointed into the chassis where you can't adjust it. The other thing is this pot looked like it's been at Davy Jones's locker. It's all rusty. Now, I did not find evidence of water, rust, or corrosion of any other kind on the board. So I'm thinking if the board had been wet or sat in a damp area, I should be finding all kinds of other rusty stuff, and I'm not. So I'm thinking that pot was probably scavenged from somewhere else and thrown in to try to make it work. I don't know if it ever did work in the power supply section. They also, previous tech had replaced the filter cap, and it is properly spec'd, 680 microfarad at 200 volt. And let's see if I can see the manufacturer. It is a Nichicon. So they use quality cap. Don't have any issues there. Just like the other Sanwas that had been worked on by somebody else in the past, we see a handful of caps that have been replaced, but not a full cap kit. Like this one back here wasn't touched this time. This one has, even though they left the glue on the board, it's not touching it. This one's been replaced. This one, nothing over in the vertical circuit was replaced. Nothing over into video processing and color. I do believe these 200 mic caps here have been replaced. The glue is broken, but it's still on the board. So what we're going to do is replace the parts that we find for sure that are bad. I'll put, what's the word I'm looking for? Breakers in instead of fuses, so we don't waste perfectly good fuses if we don't have a solid repair yet. And we'll just power test, light bulb test this on the bench and see if we get our power supply section up and working, and then we'll move on to horizontal and high voltage. Goodness gracious, I was just looking at the chassis and saw something else. This resistor right here should be a 1/4 watt. This is on the power feed coming over to our vertical IC. Experienced that in another unit. Goodness gracious, that thing is way overrated. So we're going to have to look on our parts list at R437. I believe it's 100 ohms what's supposed to be in there. We'll get that taken care of as well. All right, welcome back to Sanwa number 6. Doing a little work here on it. I've got our repairs on the bottom side and our conformal coating cured. We fixed that Q403 problem we had over here with the board. We had a pulled trace here. Let's see. There we go. Back here with the flyback, we had a pulled trace on the corner. And I've got the solder kind of bulbous to hold the board in place. Getting ready to solder our flyback back in. On top side here, this particular flyback, this piece, our flyback mounting ear was completely busted off and shattered in pieces that was unrepairable. Took an interesting approach on making a brand new ear for it. Just so happens that one of those McDonald's straws that are nice and extra large in diameter. Let's see where the remainder of my straw went. There it is. Got the large, I call them the McDonald's pipeline straws because they're such a large ID. Just so happened to be the perfect fit around the what was left of the flyback ear stub. And I placed that over it. I filled it with epoxy. Then I took the flyback screw and coated it with a little WD-40 so that the epoxy couldn't stick to it. Then I pushed the screw down in to the epoxy, let it set up overnight. Was able to unthread the screw then and had a stanchion now made of epoxy kind of covered in that straw that had threads in it ready for the screw. I put a piece of black heat shrink over it for cosmetics. Can't tell that it's there. And now we have a good solid point to screw our flyback down so it don't flex around on us. So real pleased with that little piece of work. And let's go ahead and solder this flyback back in. Now, something I have learned on this particular flyback and this particular board series with the Sanwa is these rivets. They're really hard to get the flyback out. Takes some patience and holding your mouth just right. As well as if you're really going at it with the solder and kind of pushing your solder into your pool as the entire rivet and pin heats up, all of a sudden you'll see your solder pool on top just disappear. And what it does is it runs down that leg and pools a big glob on the other side of the board at the base of that leg. And I believe that was part of a problem I saw in another unit where there was a big glob of solder on the component side of the board. So how I have started approaching this to combat that is I will heat a little solder on the pin and then just lightly tack. Not much solder involved in going around the pin. And then I'll come back to the pins and add some more solder after those initial connections have cooled. That allows me to build up a nice solder ramp around the pin and end up with a good looking connection that offers more mechanical stability than just the little bit of flow I'm doing right here that does nothing more than make an initial electrical connection. Because I want to avoid that solder pool flowing down the pin and making an unseen hazard on the other side for me. Now, most of these pads are teardrop shaped, so then I start melting my good bit of solder out on the teardrop, bring it over, and kind of quickly flow it around the pin and avoid flowing it down the hole. Just come back over here, get a good bit of solder flowing quickly to the pin, and it cools. Just my technique. Your mileage may vary. This flyback, like another one, had a loose ferrite core. Let's see here. Yeah. So I was able to take this clip off, and the two halves of the ferrite core, you know, kind of come together like a clamshell and touch on this outside edge. And I put a little bit of black RTV down in the core area where that ferrite core bar goes down, so as to keep it from rattling and squealing later. So when I found that loose ferrite core, I went ahead and solved that up. All right, here we are, back with Sanwa number 6. We're going to do a light bulb test on the power supply section. We have our 1.6 amp fuse out. We've got our new transistor in the power supply. And our new one isn't, because the old one was bad, the old one was a part number that was underrated compared to spec. So we took care of that. We have our light bulb hooked up between this side, the power side of the fuse holder, and the M1 green test wire disconnected from back here at this point. The point closest to the back edge or main power fuse is the point you disconnect. Learned this way of hooking up the light bulb to this chassis when I finally found the B+ adjustment. B+ adjustment on these is a little interesting in that you do this similar hookup, except you have the fuse in, you have the light bulb still, and you measure voltage between those 2 points and dial it into 96 volts. You have to do that on the tube and yoke, have to do it in the chassis, warmed up, and with an image on the screen. Those were the instructions that I found for this particular project. So that's where we're at. No time like the present. Fire in the hole. All right, our light bulb lights up. You know, I should have hooked a meter up just to see what our power supply voltages are. Let's do that real quick. Where can I put the light bulb that we'll still be able to see it light up there at the very top edge of the frame? Get our meter on DC volts. The easier way to do this is we hook all the gator clips to our meter leads. And we're not trying to shove so many gator clips down in the chassis to meet those points. So now we have the same points hooked to our meter and our light bulb. Let's go back to fire in the hole and see what we got for DC voltage. 82.4. I think that's a little low. I thought the bulb looked dim. We'll probably go ahead and still try to fire it up on a chassis and in the tube and see what happens. But it seems to me the last time fired one of these up, it was like 127 volts DC on the power supply with out the high voltage section energized. All right, well, we at least have a functioning power supply. Is it functioning correctly yet? Oh, I know why. Even though we can't really adjust the B plus for accuracy, we put that new B plus pot in. I bet it's turned way down. We're up to 97 volts, cranking it up a little bit. Bulb looks a little better. I'm going to say we're probably functioning fine, and it's a matter of that B plus pot wasn't turned up. Either way, I think our next step is to get it back in its metal frame. It's much easier to put those couple of screws in the frame and slide the whole frame into the tube chassis than it is to try to insulate it and make sure we don't have something touching the bottom. So I'll see you at the tube next. All right, we're back with Sanwa number 6. We have it hooked up to the tube and frame. Let's see, double check things. Got our remote board, got our signal cable, got our yoke, got our DAG ground, got our CRT board, got our high voltage anode cup. So back in here we got our power supply, our AC connected up. We have our breaker in line for our fuse. It's our 1.5, goes into 1.6, so I think that'll be fine. We've got our test point hooked up. We've got our meter connected for the fuse holder. We've got our light bulb in parallel across all of that, so we can take a look at the voltage, make sure things light up. Let's see if we get any HV, rast, or whatnot. We've got our signal generator hooked up, power, fire in the hole. Ooh, I like that sound. Kind of bright. B plus is up there at 98.2, a little high, but when we got the tickle claps. Got the vertical claps. Okay, vertical collapse. Oh, wisps of smoke. Wisps of smoke. Look like it's coming from down in here. So let's pull the chassis back out, go to the bench, see what we got. Nothing like the smell of burnt resistor in the morning. It's not morning though. It's all right, our smoke was coming from over in here. Yeah, it still smells. Oh, there it is. There's our crispy critter right there. What do we got? R304 is blackened. All right. Where does our 304 go and what does it belong to? Okay. Let's turn this up. Our 304 is right here by our vertical IC. Oh, wait a minute, that's C304. Where is R304? It's on the other side. It's on this side of here. Here it is right here, R304. That's clearly tied to our vertical IC. The other side goes to a jumper, goes to, kind of looks like a big ground plane. Yeah, because it ties over to, clear across over here to our negative on our B plus filter cap. All right, well, that would make a fella think something wrong with the vertical IC. Let's see if that 304 measures anything. Measures 97.5 ohms. It's burnt. We're going to replace it one way or the other. Our 437 is our 100 ohm coming into the vertical IC. We still have our 100 ohm there. Can I move this over and get our meter in the picture? I sure can. Like I said, our 437 is our 100 ohm fusible device, fusible resistor, whatever you want to call it, coming into this circuit. Let's go continuity. Let's find a gator clip here. We're going to tie one side of our gator clip to ground. So we have nothing on the vertical IC that is dead shorted to ground. All right. What about our R304 crispy critter here? No reading either side to ground. Actually, then that means this can't be a ground plane, can it? Or that the heat sink is not ground. Chassis about has to be. Chassis does appear to have a big ground plane around the outside. I'm thinking our B+ filter cap ground over here is the place to be. So what else is over here that we could clip onto? That solder joint's fat enough. Around 76 ohms. Oh yeah, that's on the ground plane there. That's the ground plane. That's a jumper over to there. So that is intentionally ground. The vertical IC does not appear to be at least dead shorted to ground. Let's take a look. Any of the pins shorted to each other? Nothing specifically there. That's just a coil. What about our main power feed coming down from the flyback? About R315. Vertical collapse and R304 burning up. Let's see if we can make heads or tails of that on the schematic. The tiny little schematic with a bunch of handwritten component locations on it. Is it the right diagram? Are we holding it right? What if it's upside down? Alright, where's our vertical IC on here? Here's our LA vertical IC. There is R403. So what would cause R403 to cook? R403 goes straight to our HA11423 chip. VCC's on pin 1. Boy, this is so hard to read. That might be R403 up there. That could be it down there. 304 or 403. Is the dyslexia getting me? We are looking for 304. Let's try to tie it off here. 304 comes around to C304. Okay, R304 and C304. 1, 2, 3. Our fourth pin. 1, 2, 3. Fourth pin. Yes, they are off of the vertical IC. I bet that's those couple of diodes on the bottom aren't as much modification as just a place to put them, perhaps. No, I think there's other diodes on the circuit. We're in diode check. Anything else going on here? I don't think they're touching anything, but lift them up just a smidge here. We're reading the same voltage drop both ways. $189 ohms, 265 both ways. If our fusible resistor here were burning up, I would say power supply type issue, but we didn't have any problem there. We had it on this R304 off the ground pin. Nothing is shorted there. 314 is not shorted. Jumpers will be. Where is C304 is over here. Reads 96 ohms both ways. Alright. Let's take one end each off of these diodes here. Now let's see how they read with a meter. Correctly, out of circuit. Good 1/2 volt drop one way, nothing the other. All right, I'm going to say we find a value on that R304 in our parts list and see if it measures value. Like I said, we'll replace it one way or the other because it's crispy now. R304, 100 ohm, 1/6 of a watt. I'm thinking vertical IC because I've had a couple of them already. And what was that resistor supposed to read? 100 ohm. We're going to diode check still. 96 ohm. I think it is okay, at least for continued test purposes. See if smoke rolls on it again. But we will replace it when it's all said and done. We'll get that vertical IC out of there. And the vertical ICs that are in these chassis are LA7832s. I have a replacement for the LA7832 that is LA7841. These vertical ICs are upward compatible in that same processing, just has higher current and higher wattage capabilities. So they can downgrade, so you can put a 7841 in for a 7832, but you can't go the other way because the 7832 would be underrated at that point. So by putting this part in, we're upgrading on a power handling capability and supposedly a better IC. All right, we'll swap that out and we'll give it another try. All right, welcome back. We've got our vertical IC in. We're back on the tube and chassis. We have, let's take our double check. Got our remote board on. Got our signal cable in. We've got our yoke plugged in. We've got our neck PCB plugged in. We've got our neck PCB on. We've got our DAG ground to our neck PCB. We've got our high voltage anode connected. We've got our power connected. I went ahead and soldered our test jumper back in and put the 1.6 amp fuse back in. I can pull that jumper back out after we get it fixed and we go to cap kits to finish it out. But for right now is easier than all the jumper clips. So without further ado, fire in the hole. HV's up. And there it is. For some finality, as I went back to the raster screen, took a look for good color there. More of a pure white or a gray illumination versus having the red, green, or blue tint to it. Adjusted our main drives a little bit. The grid pattern, pulled our brightness back down to we had black in the background, and then took it back to our color bars, did some final size adjustments. So she's looking really good on the screen, nice colors, good geometry, but our vertical chip was probably bad, and we had that way overrated 100 watt feed resistor right here. It looked like it was a 1 watt or larger when it needed to be a 1/4 watt. So now that we're functioning good, what I'm going to do is get our crispy resistor replaced with a new one, get our cap kit finished, double check any reflow needed, and do our final scrub-a-dub-dub on the bottom of the chassis with alcohol and a toothbrush. Thank you for joining me at Fro-Dog Arcade Repair. I hope you enjoyed the video, found it useful, or at least entertaining. Please subscribe below, like, follow, and share with your friends. And remember, fire in the hole.